So what we have here is a woman can swim u meters per second in still water. Now, I have a slight problem here with this because I usually use W to use the word water, so woman in water would be WW. So just going to rename her girl in water. So it might stay at the start of the question. Let G equal girl, which in turn equals the woman. Okay, that'll just help me out with this. Okay, so what I'm saying is that the velocity of the girl in water is u. Okay, I don't know what direction she's going in at the moment, but I'm just saying that that's definitely Fiji in water. That's the magnitude of the girl in water is u. I don't know anything about the I or J components just yet. The river flows with constant velocity speed, so the velocity of the water is it parallel to the banks. So phi w equals phi, but also phi w also equals phi because it's going straight across. There's no angles to be considered. Where phi is smaller than u. What does that mean? If the flow of the river is slower than the girl, what does that mean? She can go straight across. She has the capability to go straight across. Okay, so we have to go across there. Crossing the river in the shortest time takes 10 seconds. Find in terms of u and v the time taken to cross the woman across the river by the shortest path. Okay, so you have velocity v going this direction here. Okay, and you're here. What do you think you need to do in order to make yourself go straight across? Which direction are you going to aim in? You're going to aim diagonally left up. Okay, and you're aiming that with phi g w. The velocity in girl in water, you're aiming this direction. But to the observer on the bank, what is actually happening? Sorry, we're going straight across, okay? So we're actually going up this way. What's that called? Velocity of the girl. What is actually happening? Okay? So phi GW, for those of you that aren't here, we said that phi WG makes no sense. The velocity of the water in the girl as opposed to the velocity of the girl in water. Okay? So that's phi G minus phi W. Move it all onto one side, so what we're going to get is phi G equals phi GW plus phi W. Similar setup to last time, okay? Now, what to do? Okay, we can break up, yeah, we have to use maybe Pythagoras' theorem here. Okay, can anybody tell me what's the length of the phi GW line? Or the magnitude of it? U. What is the length of the phi W line? Phi. And by Pythagoras, we'll just call it phi G, just leave it as is. So we're going phi squared, or sorry, U squared. U squared equals phi squared plus phi G to be squared. Phi G squared equals U squared minus phi squared. Phi G equals square root of U squared minus phi squared. Okay. The reason for that is it wants you to find find in terms of u and v the time it takes for the woman to cross the river by the shortest path. It wants me to find the time taken. So u and v. It wants me to find it in terms of u and v. Okay. So this is quite easy now. It's actually ridiculously easy now. Okay. So all it wants me to do is distance over time. I'm not even going to use the 10 seconds, which to me is completely perplexing. It's like the 10 seconds is a complete misdirect. It wants you to find in terms of u and v the time it takes for the woman to cross the river by the shortest path. Okay. The width is d, which is this here, and my speed, so distance over time, distance over speed equals time. We know the time's 10 seconds, but it doesn't want that according to the language of the question. What I want you to write down is d equals the square root of u squared over v squared. Now, basically, because it says in terms of u and v, so you see it in terms of u and v, there's no mention of the variable d, so therefore currently d is my problem. I need a way to get rid of d. Alright, so d equals vp over u. Okay, so time equals distance over speed, and we have that going up at u. D equals 10u. Okay. What we have here is this, guys. See, crossing the river in the shortest time. Crossing the river in the shortest time actually has nothing to do with what we're doing here. We're doing the shortest distance, aren't we? Not the shortest time. So this complete setup here, everything we've done thus far, is all based on the shortest distance. My problem happened is that I came across D. I'm currently not able to get rid of D, so I have to go back to the start, and everything I've done is correct, but what I have to do is I have to figure out D in terms of U or V to find out what the shortest distance is. Now the shortest distance is very easy, guys. All you gotta do is see your distance D here. All you have to do when you're doing the shortest distance is just aim all your speed directly upwards, and you automatically get dragged across anyway. So when you're swimming this time around, you're going to aim all your speed directly upwards. So you're going to aim all your u directly upwards, and what's going to happen is v is going to drag you to the right, and then you're going to go across at this direction here, which is technically the square root of u squared plus v squared. But you don't even need that, okay? Because also you need to be worried about is that the vertical component is d, isn't it? So you can just do time equals distance over speed again. Time is 10 seconds. Your distance is still d, but your speed going straight up is u. Therefore d equals 10u. And then you replace that d with 10u, so you get 10u over the square root of u squared minus v squared. So key part of this question is the word shortest time is one part of the question, and then shortest path requires a completely different setup. Okay.